Today we've got a scruffy radio. It's a Uniden, it's an Audioline 341, isn't it? Does it still say so on the back? Yeah, 341. We saw this again before, about 15 years ago. And it belongs to somebody who I know. And I might put this through the dishwasher because it's pretty scruffy. Now I understand he's connected the power backwards. They're the wrong screws. And this gentleman is, although I know him reasonably well, he's a bigger friend of Stuart. Stuart's already had a look at this, and I think there's some burning out of something or other. Now it smells like it's a smoking household, and so I can't tell what's smelling of smoking or what's smoking that smells. Do you understand that? Oh dear, that was a good one, wasn't it? I think that's heading for the dishwasher, minus the speaker, of course. So what Stuart was concerned about, just make sure we're in the right on the right camera, is down here. Those coils are pretty frazzled. So I think we'd better just take off the other. I've not seen a Uniden for months. It's funny how these go, you know, you see loads of the same sets and then you don't. I'll just put the cases on top of the multimeter. That was clever. Not. So if we look for the protection, I'll just return the camera to its normal position. So protection diode looks to be short circuit. It's possible it's protected it though. I think this is one that Stuart sorted out about 15 years ago, and it just came to me to actually be tuned. What I don't want to do is to break the protection diode. You know, I've been unsoldering things for 38 years. Why hasn't that come out? I particularly want to get this out intact. Yeah, that's got a nice crack in it. So I'm sure that when we test it, that was the short circuit. Yep. Right. Put that in the vertical filing cabinet. I'll just go to stores department and get one. So now we've replaced the protection diode and we've put our famous crocodile clips onto the power connector. I don't have Uniden power connectors on here. We don't have any power on the radio. So is one of those chokes actually burnt out? So make sure we've got power on those clips. Yep. So have we got power? We haven't got it on down a negative one. The negative one is open circuit. So actually managed to burn out the choke I don't think he's got, as I said before, I don't think he's got the right fuse or any fuse. Is it that one? It is. So, I've never seen one of those burnt out before. What can we pinch one off? Pause the video while I look for some scrap. Right, so that's wired a Uniden mic up. Let's put something on the signal generator. We're on channel 20, so 2779125. Diff as a post. That might be the RF gain. It is. Okay. So we'll select picture in picture. That should bring us... I've got the wrong glasses on to see whether that's brought up picture in picture. Yes, it has. Whoa. Actually doing slightly high. That's a peak. 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 £4. Now you can't adjust the frequency on these, but we'll just monitor it and make sure it's within acceptable limit. Should be 27.79125, 27.79108. Fair enough. Deviation. Wallow. 1 to wallow. 1 is very, very slightly high. Wallow, 1 2 1 2, wallow, 1 2, wallow. Yeah, that's right. Now, I'd better check the RF meter's reading something sensible. No, it's not. Center of the red zone. Now we'll check the radio on low power. Should be 0.4 of a watt. It's 0.1 of a watt. It's one of those, is it, which is a bit iffy. Well, he won't want me to spend money doing that. It's 0.17 of a watt now, so that's fair enough. What does that leave us with? I'd previously done the 2 capacitors 15 years ago, which play up in these radios. Just go through the receive. So check the detector. So to do that, we'll put on the oscilloscope. I get quite a lot of inquiries about this oscilloscope lark. We're only looking at audio. Put an S9 signal on there. You don't need a 30 meg oscilloscope to look at the audio. These oscilloscopes, because I particularly wanted CRT ones, because I don't want this latency, this lag. I don't want to be a just wait. I want to see instantly, and that, to my mind, can only be done with analog instruments. So I bought these only 2 years back, and they're about 100 quid each from China. ST16Cs, we've got 2 of them. But there's so many, £5 oscilloscopes on eBay because, people aren't interested in that kind of thing. And there's those new little 2-inch digital things. It's not my cup of tea. We have got one, we have demonstrated one, and that's all you would need. It's not some great big expense. Now I've got the signal generator generating this tone, but you could just as easily generate that tone yourself with a kid's walkie-talkie like this, and you just press the call tone, and it's going to make the same kind of noise, and you can tune it up. So, it can be done cheaply and on a budget, and I've shown that before. So, detector coil. It's going to be that one, isn't it? Yep, spot on. But if you don't get that right, you're going to end up with garbled receive. We'll just run through the receiver. And I'll use the ceramic tool. And then we'll just put a bit more signal on to do that one. Not that much signal. See what the cyanide reading is. 0.78, 0.79. These aren't the most sensitive sets in the world. That's probably why they don't get the bleed over. We have had some, it's like anything else, there's a good tolerance between them. So, I think we're going to have to take the front panel off if we can, easily, and put it through the dishwasher. The whole thing is scruffier than I would like to see. So, we need to do the signal meter, so I'm going to put S9 on the radio. I never showed you the cyanide meter, sorry about that. Just realised we've still got the oscilloscope on the screen. So, what shall we go to now? The Attenuator Controls. We just need to check that's S9. It's very, very slightly out. And then we just need to check the squelch. So I'm going to turn the squelch to full. No, that's mic gain. Don't say I didn't have the mic gain up when I did the deviation. So the squelch is on full on the radio. So I want to be able to put 100 microvolts on here and it comes through. 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. It's a bit strong, that, so we'll just pop it down a bit. Whichever down is. Oh, is it going to be like that? So that's minimum. Okay, so on this one it's 300 microvolts. Well, I can't do anything about that. So we'll now turn the squelch down, check it for sensitivity on the threshold, put the signal generator back on, see when that comes in. About 2.8 microvolts. So it's a bit of a strong squelch. There you go. What we'll do is to put this through the dishwasher because it's scruffier than I would like. So I'll see you all in an hour. Okay, so we're back together. It's been through the dishwasher on a pretty low cycle, not wanting to melt it. But it certainly got rid of a lot of the muck out of that. It's not fully dry on the front panel, but let's see what we can do. Mic gain, RF gain, squelch. Usual off-frequency chat from people using illegal radios. Well done, Roger. Hopefully we're on full power. One down to Roger. I can't listen to that. It's too annoying on the ears. So there we go. Audioline 340. There won't be an on the air test. Mr. Chippy isn't here, and we know that it was a working radio anyway before that problem happened with its power. So, thank you for watching the Audioline 341 from 1981.